SEERS is one of the 13 early release science programs that had data taken back in June of 2022. This field has been extensively studied with Hubble, so we could do a direct comparison of what galaxies look like with JWST and with Hubble. This image shows a mosaic of those first June NIRCam pointings. You can see all 4 pointings lined up here. And here is a selection of what just a few of these high redshift galaxies look like. In total, we analyzed 850 galaxies at a redshift greater than 3 that were also detected in Hubble imaging so that we could compare them directly. Each of our classifiers were asked to determine whether they saw evidence for a disk in the galaxy, a spheroid, or irregular features. And they could choose multiple of these categories because galaxies are complex and they don't necessarily fall into just one box. From Hubble, we knew that galaxies with disks make up about 45% of galaxies at redshift of 3, and that fraction declines with redshift, particularly at a redshift of greater than 4. We see similar things with galaxies with spheroids and galaxies with irregular. This decline is largely driven by the large fraction of galaxies that are unclassifiable or unresolved in the Hubble imaging. They were just too faint or too small for us to be able to see anything. When we look at the same classifications with the JWST data, essentially everything jumps up. All of the fractions are now higher. So disks make up 60% of galaxies between redshifts 3 to 5, and then slowly declines to about 30 to 40%. Spheroids and irregulars make up a roughly constant fraction across all of these redshifts. There are a number of reasons for the changes in morphologies we see between Hubble and JWST. One is the increased resolution of JWST. We can now see finer details that allow us to see the structure more clearly. Another is that the infrared capabilities allow us to see the rest frame optical light at higher redshifts. And the other is the improved depth. The high sensitivity of the NIRCam instrument allows us to see faint features that we simply couldn't see before. And so, for example, if we just look at the second object here in this row, if you only looked at the Hubble imaging, you'd probably say this is a spheroid. It's small, it's round, it's compact, you don't see very much structure. But with the JWST imaging, the surrounding disk around this galaxy becomes clear. So we're able to see a lot more of these features. So we can really start to look at samples of thousands of galaxies at these redshifts and really start to quantify when the first disks and bulges were able to form in our universe.